All right.
All right, I'll start sharing my screen here. Can you see that? All right. All right, we'll get going here with the introduction to Rook and teach a little bit about Rook, how to get going, what it's all about, and how to start a development environment. Anything else before we get started, Sage? All right, we'll go for it. So Rook is it's an orchestrator for Kubernetes that brings storage to Kubernetes. Historically, storage has been something that's external to Kubernetes, and Rook's goal really is to make storage a first-class citizen of Kubernetes. The place we started is with Ceph, and so I've been with the Rook team for the last couple of years. And early on, we made a bet. We said, "Yeah, we believe in Ceph. It'll work great for Kubernetes with some work to integrate it natively." So that's Rook's goal, really, to bring file, block, and object to Kubernetes, make it simple, make it manageable, and automate as much of it as we can. So what I have here is just the rook.io site to get going. Now, if we say, well, where do we start? I'm just going to go right into a demo and bring up a sample environment. So on the Rook GitHub page here, the easiest place to get started is by going into the test folder. So the test folder has some instructions on how to start your cluster. Right? Now, there are a number of ways to start up Kubernetes, and what I'm going to show today is how to start Minikube, which is the simplest way to start up just a single node Kubernetes cluster. So on this page, we see in the Rook repo, we have a helper script, minikube.sh, where we're just going to say minikube up, and it will give us our one node cluster. It takes 2 or 3 minutes to get started. So just before this, I started up a clean minikube here. So if I switch over to my console, we've got minikube up, and what this does is this is just a few basic commands to starts up a VM, it starts up the Kubernetes 1.10, or you can give it a different version. And after Minikube is running, it will go ahead and load my private build of Rook that I've built locally here on my Mac. It'll push that into the Docker registry for Minikube to use. So basically, I can build locally, start at Minikube, and it'll use my private build. So once we have Minikube up here, now I should be able to say for my Mac, Coop Cuddle, get nodes, just to show what's running. So we have one node running here. Is this font big enough, by the way? Okay, I'll assume so. So now that we have our Minikube cluster running, now this is, you can use a number of virtual node or virtual machine plugins. This is using VirtualBox for me. So to make the demo a little more interesting, I added some disks to Minikube. So just to add one more here. So if I go into Minikube storage, I've already added 3 disks that we can run OSDs on. And I'll add one more just to show how I did this. I'll create a VHD and call it disk number 4. All right, so basically in this VM, I've got 4 devices, which now we can create an OSD on each one of them. And by default, Rook actually doesn't need those devices just for a simple testing environment. So it's not too often I go create those devices. By default, Rook will just create a single OSD in a directory using file store. But for this demo, I'll be showing 4 OSDs on BlueStore. Okay, so now that we have our Minikube up, let me show you what happens when we want to start Rook. All right, so the entry point for Rook really is what we call the Rook operator. The operator is the thing that manages the cluster. It manages the health, makes sure that the cluster is healthy and running. So here we have our operator.yaml, which shows basically we're going to start a Kubernetes deployment. It's going to start up a pod that will run our Rook Ceph image. And I'm just using my local build. But this will start up all the Ceph daemons. All the Ceph daemons are contained in this one image here. So including the operator itself. So if I go ahead and start that, I'm going to switch over to this window here. Cuddle create the Rook operator. Okay, so what I just did, started the operator, and it starts a couple of other daemons as well. So if I get, let's look at what I did. So Coop Cuddle get namespaces. So then what we just did is we created a Rook Ceph system namespace. And this is the namespace where several pods are going to run. So if I look inside that namespace, Rook Ceph system get pod, the first thing we see here running is the operator. So that's the operator is going to manage our cluster and make sure our desired state is applied. The agent is a pod that's going to be running on all the nodes as a daemon set to mount the storage on the pods that want to consume it for blocker file. And then we have this other pod, discovery pod, which is going to discover what devices are available on all the nodes. All right, so at this point we have the Rook operator running, but we don't have any of the Ceph daemons running yet. And to do that, we've got another YAML file. So that was the operator. We'll move up to the cluster.yaml. So when we create a Ceph cluster now, we're going to start it up in a different namespace. So we start it up in the Rook Ceph namespace. And these are all the custom settings that we need to start a cluster. This is what's called the Kubernetes CRD. And the operator is going to go apply the settings here. So I'm saying I just want 1 mon because it's a simple 1-node cluster instead of the default of 3 mons that you would need in production. This is a new setting for enabling the dashboard. So I just say, yep, I want the dashboard, and Rook will go start it up. And then I'll skip down to a couple other settings here. Use all nodes. It's going to say, whatever nodes I have running in Kubernetes, go look for storage on those devices and start them up. And there's a couple different modes. I can just tell it, go look for all raw devices that are not being used by someone else and consume them. So since I created those 4 devices in Minikube, we should expect to see that Rook is just going to find all 4 of those and start up OSDs. And a number of other settings that we won't talk about here. So in a nutshell, if I go create this YAML file, go back to the console, Coop Cuddle, create cluster. Now this creates this namespace, and then it's going to start up the cluster. So our cluster CRD is created, and the operator is going to wake up and it's going to say, oh, I see that you created this this Ceph cluster object. I'm going to go start up all the mons and the OSDs and the manager to get a basic Rados cluster going. So in this new Rook Ceph namespace, we say Ceph, show me the pods. So it looks like it's already completed the basic pods here. So the mon was the first pod it started up. And since I just requested the one mon, we only see the one pod. There would have been a separate pod for each mon. And the mon ID is also in this name here. We start up one manager, and basically even in production clusters, we just start one manager and rely on Kubernetes to restart that daemon if it fails. And then we have one OSD pod. Today we have one OSD pod per node, but that's going to be changing soon. So we have one OSD pod per device. Okay. So now let's go look at what's happening inside Ceph. So that I can actually connect to any of these nodes and run Ceph commands inside of them. So I'll just connect to the OSD pod. So in the Rook Ceph namespace, exec. All right, and if I typed that right. So now we're inside of the OSD pod, and we can run the Ceph commands. So if I say Ceph status, we should see, yep, I've got a mon that's in quorum. The manager 0 is active. 4 OSDs, and they're all up and in. And then we don't have any pools or objects yet consuming the storage. Okay, so let's do something a little more interesting here. So as part of the manager, there's a plugin for the dashboard, which we told Rook that we wanted to enable that dashboard. So let's go see how to bring up the dashboard now. Now, if I look at the services, if I type that right, get services. So a service is basically an endpoint and a load balancer that directs traffic to different pods. So the Ceph manager created a dashboard pod, or service, sorry, that will expose port 7000, which is for the dashboard, and it will expose it on this cluster IP. Now, by default, this is just an internal service for the cluster, and you have to be on one of the Kubernetes nodes for that to work. Right now, I'm on my Mac, and so that won't really help me. So we've got another example where we have to create another service that exposes it with a node port. Let me create that, a dashboard external, and actually let me come show this example. So this example says, create me a service that exposes port 7000 from all of the Ceph manager node pods, and it's going to use a node port, which is basically going to choose a node or a port on the Minikube node to expose externally. So now if I look at the services again, we should see that we now have an external service, which is the internal port is 7000 and the external port is 32058. So now if I have the host IP for Minikube with this port, we should be able to see the dashboard. So real quick, to get the IP address, I'm going to go inside Minikube and a quick ifconfig look for ETH1, which has the address we want. Okay. So I copied that. And now if I go over to my browser, new tab, so there's our IP address. And again, port 32058. And here's our dashboard. So just like we saw from the Ceph status inside the pod, we have one mon, no file systems. There's the manager, 4 OSDs up and in. Great. So with the dashboard in the background now, let's go create some more, some pools and file systems and object stores inside the cluster. Now let me go back to these samples here and show you. So we've got a file system. So this is another CRD that Rook is going to watch and apply the desired state. So the file system is going to create one metadata pool. Actually, we can change this to replication of 3. For the data pools, we can use erasure coding since we have at least 3 OSDs. And then there's some settings for the MDS server here, where we'll get one MDS and have an active standby as well for that MDS. All right, so let's create this. So Coop Cuddle, create file system. Oh, and before I hit enter, I'm going to put the dashboard in the background here. So now the operator sees, oh, you want a file system. I'll go create those pools that you wanted. So you see these pools starting to show up, MyFS, metadata, and the data. The PGs start appearing, and before long we have our pools active and clean. Okay, and now we have our file system. Looks like it's taking a minute for the PGs to stabilize, but again, in the dashboard here, we can go look at the file system. And in a minute, it should be all good. While that's stabilizing, let's go create an object store. So it's a similar concept. We're going to create a metadata pool and the data pool. Actually, multiple metadata pools are needed for the object store, and we use the same pool spec to create all of those pools. Oops. Oh, go back over here. Coop Cuddle. Create me an object store. So Rook wakes up, starts its creating those pools. The RGW control, the metadata, the log, and eventually we'll have the RGW service running as well. So let's see what pods we have running at this point in our namespace. So remember, we started with the manager, the mon, and the OSD. So now we've created a file system with one MDS and one standby. So those pods are both running. The RGW now just has one running, or I think there's just one. Yep. Piece of cake, right? So we've got a file system and an object store, a number of pools, all created, whether I want a replication or erasure coding. It's all running. And the dashboard here in the background to help us troubleshoot. Now, I'm not sure about what happened with these metadata PGs. That's something to look at later. see the logs here showing all of this. But okay. So let's say we wanted to actually go look at those PGs and troubleshoot. Now we could just connect to one of the pods again, but I'll show a sort of what we call the toolbox pod. So if I create one more YAML file, so the toolbox is where we've got the Ceph tools and a couple of others, like an S3 client that lets us, or S3 command to test out the object store and some other things. But if I connect now, let me get the name of the pod. So if I connect to the tools, like I'm trying not to use my aliases or it would be much faster here. All right, we're in the toolbox. If we look at the any Ceph command, let's look at our OSDs. Okay, the OSDs are up. Any other commands? We could go execute any of the Ceph commands to go troubleshoot what's going on with those PGs. Let's see, what else could I show? There's a couple of Kubernetes things to show. Let's say that one of our pods dies. One of our daemons goes away. Kubernetes will bring it up automatically. I'm going to go ahead and just delete one of these to say, and see what happens. So let's say I delete the manager pod. And if I said delete pod, okay, the manager pod has been deleted. Now let's see, the dashboard may become unresponsive here unless the pod already started up again. Let's see if it started up again. So get pod. The manager already started up again really quick, thanks to Kubernetes, making sure our pod is always running. Other ways to troubleshoot. So let me show you a little bit about what happens inside of the Rook operator. I'm going to expand this a bit here. So back in the Rook Ceph system namespace, remember we have the operator pod. So the operator pod is what's making all of this happen. So if you really want to see what's happening in there, you can say, look at the logs. Okay. Now the last thing we did, the last CRD we created for the operator was to start an object store. So at the very end, we see that it was done creating that object store. And it won't be very interesting to look through all of these logs. But if you were to look through all these logs, you'd see that all Rook is doing really is running commands to go run the Ceph tools to start up the different daemons. Starting up a mon, generating config files for you in etc Ceph, so you don't have to worry about generating config files. Make sure we have mon quorum. If you have multiple mons, it will cycle through and make sure you have quorum and you maintain quorum. Initializes crush maps, and here's where we started up the dashboard. It just said, "Nope, enable the dashboard for us." There's another. We also enabled the Prometheus module by default, so you can collect metrics and show a nice dashboard separately. Anyway, so the logs are really useful to look through the operator, as far as what's happening in your cluster, and if things are being created, if you need to troubleshoot. Operator logs are helpful. The logs from any of the other daemons are going to be helpful as well. So if I look at these other daemons, we see the mon. Let's see. So the mon logs are doing what mons do best. OSD logs. The OSD logs will be interesting here to show what Rook does as far as starting up each of those OSDs. If I look in the OSD pod, I'll expand this a little more. Let me go back to the top of this log and show how we started up here. It's going to be way up here. Just a second. Okay. And almost there. Lots happen to the covers. You probably don't want to dig through these logs too often. What happens is when the OSD pod starts up, it's going to use lsblock and say, hey, what devices are available? Do they already have partitions on them? Are they do they already have a file system on them? And make sure we don't overtake them if we're not supposed to use them. And after we see that, in this example, SDA, it's already in use. Rook better not use it. But the other devices, I found, STD, STB, SDE, SDC, all these devices are available. So then Rook will go through one by one and make FS and initialize them for Bluestar. A lot of Ceph commands that if you've set up a cluster on your own, hopefully you can appreciate just how much has been done for you. So starting up a cluster is really easy with Kubernetes and with Rook. So that's pretty much my demo. Any questions so far?
I had a quick question about how you consume the storage. If you're using sort of upstream Kubernetes and you're deploying Ceph independently, and you want to use volumes that are provisioned in Ceph, you have to set up a dynamic provisioner, I think it's called. So right. It's not a CRD, but it's another thing you have to declare in your cluster. How does that work with Rook?
With Rook, yep. So so Rook has a volume provisioner and it uses a flex volume plugin that makes it really easy to mount the storage in your pod. So we've got a sample here, which would be good to show actually. So we've got a WordPress sample which runs MySQL behind it, and MySQL of course needs some block storage. So in this MySQL YAML, which is a bit long, let me see where we consume the storage. So this MySQL pod is going to use this volume, which is going to use a persistent volume claim, or PVC, of this name. So MySQL PV claim is what we need to go look for. So then up here higher, we see that this PVC is based on the Rook Ceph block storage class. So we've got the storage class for Rook that then allows us to provision the volumes dynamically. And I'll start this up in a minute. And yep, so that's the important key here, Rook Ceph block. So now if I go back and show that storage class, so the storage class, Rook Ceph block, uses this ceph.rook.io/block provisioner, so that when somebody wants to provision a PVC using this storage class, the Rook provisioner will be called in the operator, and the operator will go and create an image for consumption based on the pool that you tell it. So in this case, we were using this thing called a replica pool, which then in this other CRD, we've got a pool CRD. We create that pool that can be consumed. All right, so just to show this more end-to-end here. All right, where were we? So Coop Cuddle, create storage class first. So pretty much immediately, Rook creates this pool and then that storage class. Now let me look at the dashboard to make sure we're up. Yep, so replica pool. Yep, it's up and it's clean. Now, to start up the sample, we need the WordPress Docker images in, and I've got in our script here, I'm going to run this real quick. So this will take the Docker images that I've already got locally on my Mac and just push them into the Minikube VM so that we don't have to wait for them to download. So this will just take a minute to load those. There's a MySQL pod or image and then a WordPress pod. Okay. But we can start creating this over here. So now if I say create the MySQL, oh, it's up a directory. Create the MySQL pod. Okay, at this point, the PBC is created. The operator is triggered to go create that image. Let me see if I can go find the operator logs. Is this what I, yep, that was my last command. All right. So we see now at the end of the operator log, and we create a volume from the replica pool. Oops. It creates this PVC with a big, long, ugly name. RBD, it makes sure it was created. Creates the block image. It says, yep, successfully created the Rook block volume. And then it uses a flex volume driver. And then this flex volume driver is running on all of the nodes in the cluster. It started by the Rook agent pod that we saw in the system namespace. So when the request comes in for that storage, the flex driver is then able to go mount that storage on the node. Okay, so if we were to go look in the kubelet log on the Minikube node, we could see some messages about the mounting through the flex driver. Let's see. So let's make sure the pod is running here. Coop Cuddle. So this MySQL pod is now running, and it was able to mount the storage successfully. See inside a little more detail about how that happened. We can say, we're already in the default namespace, describe pod. Okay. So at the end, it shows the events that are going on for this pod. We see that this PBC was created. This PBC, somewhere up here it mentions Rook. It's from the volume MySQL persistent storage. Which if we traced it back again, we would see that Rook created this thing and mounted it. I guess while we're at it, I'll go show the kubelet log, because if something doesn't get hooked up quite right and the volume won't mount, sometimes there's issues with flex drivers in different environments. Flex drivers are a bit challenging sometimes. So soon we'll be having a CS driver. We'll talk about that in a few minutes. But the CS driver will be a little better that way. All right, I'm going to go inside Minishift, not Minishift, Minikube, and look at the logs. So if I look at kernel CTL, the kubelet. So the kubelet is the daemon running for Kubernetes on the nodes that does attach and detach of the volumes. It calls into the flex drivers. So we should see here, we've got some detach actions. It's rather verbose in here. Yep. Volume detached. Is this? I feel like I'm missing something. Yeah. So So flex volume Ceph Rook.io. This is where the attach started for volume. I was expecting to see a completed message. Let me just go to the end of the log one more time. I guess that's it. Yep. So it goes full circle and mounts that block storage for you. Okay. Other questions? All right. Well, if we talk about the roadmap, where are we going? Rook has a lot going on. A lot to do with Ceph too. Really, our next goal with Ceph is to get it to production ready. Ceph itself has been production ready for years, but inside Kubernetes, making sure it's orchestrated and stable in that environment. We're getting close. The CSI plugin, as I mentioned, is an area where we'll be going and working on next. The Flex driver is working in the meantime. CSI is just the next way to work across multiple orchestrators, Kubernetes and Mesos and others. Rook is still just focusing on Kubernetes, but CSI could enable other scenarios there too. Something else Rook is doing is supporting multiple backends. So Ceph is what we call our first backend, and the only one today. Now at KubeCon a couple of weeks ago in Copenhagen, there was a demo showing other backends that are coming soon. There's like starting up Minio, starting what was the other one? Anyway, starting other backends with the idea that Rook will be the place that people come for storage solutions in Kubernetes that are integrated with CRDs.
I think it was CockroachDB.
Yeah, right. Yep. And yeah, we just merged the PR a day or two ago that enables multiple backends. And so yeah, we should see in the next week or two those other backends coming in soon. But yeah, it's come a long ways. It makes Ceph a little bit easier to run, and we've had a good time doing it.
Yeah, I'll just add a few things. This is Sage. I think the main thing to mention is that Rook is the preferred means for deploying Ceph in Kubernetes from, I think, both the upstream perspective and also from the Red Hat perspective. This is sort of our path forward, and our efforts are going to be focused here. So if you're looking at running Ceph for your Kubernetes deployment or running Ceph inside your Kubernetes deployment, this is where you should be looking. There is a Ceph Helm project that we were playing with earlier, and that's still, there's still a repo under GitHub, under the Ceph org, and some people are still using that. But what we found when we were working on that is it was awkward to manage Ceph using sort of just the low-level primitives that Kubernetes provides. And we really wanted this operator pattern where you have something that's smart, that can pay attention to what the cluster is doing and do things in a particular order and so on. So everything from, if you add more monitors, making sure it adds them one at a time and you maintain quorum, or if you want to move a monitor, it like adds a new one first, waits for quorum, takes the old one out. All those sorts of things that you need to be careful about to maintain availability is intelligence that is either already built into the Rook operator or can be added later. Another big item in that category would be upgrades, where usually when you're making a major upgrade between, Luminous and Mimic, or Joule to Luminous, or whatever the upgrade, there's usually a sequence that the daemons have to be upgraded in. A lot of times there are special steps to be taken to make sure that you are transitioning and enabling features and so on. And so that intelligence to orchestrate those upgrades will be encoded into the Rook operator, so that when you do make a major upgrade, you'll basically update the Rook operator pod and restart it, and then you'll just tell Rook, I want to be running Nautilus, and it will go and it'll do all the right things in the right order with all the right weights and safety checks and everything to make sure that process happens smoothly. Let's see, John isn't on the call, John Spray, but one of the big pieces that he's working on right now is building an interface inside the Ceph manager that is sort of a simplified set of things that the dashboard and the Ceph manager and CLI and so forth can do to talk to whatever the underlying orchestration engine is. So he's prototyping all that with Rook, so that the Ceph manager basically knows that it's deployed by Rook and can talk to Rook to do stuff. And so the first thing there is that, for example, in this test branch, you can look at devices and create OSDs from the Ceph command line, and it'll basically, Ceph will go tell Rook, go create an OSD pod over on this host or whatever with this device, and they'll start up the OSD. And eventually that'll all be plumbed into the dashboard, so the dashboard will let you deploy new OSDs or expand the cluster to hosts or change the number of RGWs that you have running, or all of those sorts of cluster management things will be possible. And it's being done with a generic layer, so you could also have implement it with other orchestration tools like Ceph Ansible or DeepC or whatever else. Whoever else wants to go to the effort to implement that.
Yeah, cool. Yeah, the upgrade will be a big one. Just even Rook upgrading release to release is quite a process. So even adding another, I think Ceph under the covers upgrading. Anyway, it'll be just a good thing. I joined Red Hat a couple months ago with the intention of making all this work even better. And anyway, excited to be working on it. Any more questions? I still want to know why the PGs didn't come up active clean.
Yeah, I think it's because you said multiple replicas, and probably by default it's using a crush rule that wants to separate across hosts. And since this is Minikube, you only have one host.
Okay. Okay. I did change that at the last minute, so.
Yeah. That's what you get.
Well, let's just try this. That's what I get.
Yep.
Demo can't go perfectly.
Yeah. Yep.
Okay.
All right.
Thanks, everyone.
One last thing to mention. I think you said this earlier on, but one of the main change that's currently in flight is Waman's work to change the way that the OSD pods are created. So right now there's one Rook pod that has all of the OSDs. Very shortly that'll be a pod per OSD with the new device discovery and stuff, a whole bunch of new infrastructure to manage that.
maybe just to show what that will look like. Let's see, get pod. Yeah, so right now we only have the one OSD pod per node. So in the future we'll have one OSD, so one pod per device. In this case we'd have 4, and the OSD names would also be in the pod name to make it easier to troubleshoot where the OSDs are and look at just their logs and things when there's issues. So that'll be a great change coming.
Is it going to be possible to do the same thing with the other daemons? Like I noticed inside the cluster, it's manager dot rook dash stuff dash manager or something like that to make the pod name match the stuff logical name.
Match that. Let's see. So like the like Rook Ceph manager 0, like this guy.
I guess it does match.
Yeah,
okay.
Yeah. I think after the OSDs are done, it will match. Kubernetes just puts these ugly suffixes on because of the way it starts up the pods from deployments and replica sets. But if you look at the first part of the name, it should match.
Okay.
Yeah. Mm-hmm.
Cool.
Yep. Mm-hmm.
Jan has a question. Can Rook deal with IPv6 Kubernetes clusters?
There's someone opened a PR on that, and I haven't tried it myself, but I believe it. Well, somebody's been working with it, so I think it works. But I'll have to double check the status of that request. Yeah, it's a good question.
Yep. Cool. All right.
Call it good for today.
Yep. All right. Thanks, everyone.
All right. Thanks.
Have a good one. Thanks, Travis.
Mm-hmm.